Hello dear students. So today I'm going to cover vectors chapter in the NSEJS Basics to Advanced series. I'll give you a brief detail about what we cover in this series. So this is the sequence of topic in which the sequence of chapters that I'm going to cover, and we have covered the calculus part, and today we are starting with vectors. It is going to be the first lecture of vector, so it's going to be very important also, guys. This is something which may be absolutely new to you and very important also, so pay very careful attention. All right, in this chapter we have to learn all these things: terminology, notation, vector addition, unit vector, resolution, dot product, and cross product. Out of these things, today what we are going to learn is this. Okay, today we are going to talk about the different terms that are present in this chapter. We are going to talk about some properties of the vectors, and we are going to talk about how to identify angle between the two vectors. So these are the areas that we are going to cover in today's session. Let's begin. So guys, to introduce this, let me first give you a question. Let me ask you a question, or rather there are three questions, and I want to ask you all these three questions. So 2 months back, Ram had a mass of 60 kg. He lost 6 kg due to illness. What is the current mass? What is his current mass? That is your question number first. You can think about it. You can reply in the comment also if you want. Sham ran 10 minutes on a treadmill, and then he did cycling for 20 minutes, and then he left gymnasium. His workout duration was how long? What do you think, guys? What is your answer? And the third question is, Rahim walked 5 kilometers after leaving his home. Then he walked he walked for 5 kilometers more. So how far is he from home? Like how much far he is from his home? So if you think about these three answers, possibly for this answer you have replied as 54 kg. If you did that, that is definitely the right answer. For this, you probably replied as 30 minutes, which is again the right answer. But in the third case, if you replied 5 plus 5, 10 kilometer, now I would say that it is one of the many possible answers. Okay, it's not necessary that the answer will be 10, because the question says that Rahim walked for 5 kilometers after leaving home, and then he walked for 5 kilometers more. But what the question doesn't tell us that in which direction did he walk 5 kilometers more. For example, I'll talk about two most common scenarios. The first scenario is that he walked 5 kilometers in certain direction, and then he continued walking in the same direction. In this situation, he would be at a distance of 10 kilometers from his home. I hope you all agree with me on this. The other scenario is that he walked 5 kilometers in one direction, and then he reversed. He walked back to his home, when it was said that he walked for 5 more kilometers. So in this case, he will reach his home, and the distance from his home now would be 0. So these are two possible scenarios. If I ask you, are there any other possible scenarios? Well, I can certainly think of some like this. He walked 5 kilometers and then he turned by 90 degree and he walked 5 kilometers more. All right, in this case, will you be able to tell me that how far is Rahim from his home? I think you all will agree with me if I say that this distance would be 5 root 2. Okay, so that would be the answer in this case. So we have seen that 0 was one of the answers. Okay, 0 was one of the possible answers. Okay, 0 kilometers. Okay, then 10 kilometers was another possible answer. Okay, 5 root 2 is another possible answer. So are you able to think of any more possibilities also? Okay, because if you ask me, then yeah, there are certainly some few more possibilities exist. For example, Rahim could have walked 5 kilometers maybe in this direction, or maybe in this direction, or maybe in this direction, or maybe in this direction, 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 maybe here. All right, and depending upon in which direction Rahim has walked, his distance from house would vary. Like suppose if this was the direction that Rahim chose, okay, then this distance will be the answer. If this was the direction that Rahim chose, then this would be the answer, and so on. So the answer will vary. And you know what, with this consideration, you can possibly tell me that what is the minimum answer that we are expecting and what is the maximum answer that we are expecting. Can you tell that, guys? If you can, well and good. If you can't, no worries, let's continue. We'll talk about it later on. Okay, so what I learned from here that if we consider these three questions, it was possible for me to answer the first two questions without thinking about or without getting any other additional information, without knowing about directions. In the third case, it was imperative to know the direction in which Rahim is walking. His first 5 kilometer and second 5 kilometer, what is the angle between these two? Okay, only then we could arrive at the answer. So there are quantities in physics such that when you try to deal with those quantity, you don't need any additional information except their value, except their what we call as the magnitude, except their numerical value. If you have their numerical value with you, then you have complete information of those quantities and you will be able to use them properly in your calculations. Such quantities are called as scalar quantities. All right, if you are trying to deal with scalar quantities, you don't need any additional information. Mass is an example, time is another example. Okay, but then there are quantities in physics, if you are trying to use them in your calculation, if you're trying to deal with them, then apart from knowing their value, you must also be aware of their directions. Such quantities are called as vector quantities. So if I show you the definitions, okay, scalar quantities are those physical quantities that are completely described by their magnitude only. Okay, the most common examples are mass, time, speed. Okay, and there are a huge number of such quantities you will come across when we study different chapters in physics. All right, similarly, this is scalar quantity. If I talk about vector quantities, these are physical quantities that are completely described only when we have the knowledge of their magnitude as well as their direction. If we don't have their magnitude, or if we don't have their direction, then we will not be able to use these quantities in our calculations. All right, so examples are displacement, velocity, acceleration, force, momentum. Okay, all these are examples of vector quantities. Okay, now if we have understood that there are some special quantities and we need to be aware of their directions, we need to be aware of their magnitude if we try to use them in our calculation, the next thing that we should ask ourselves is that how do we represent such quantities? So if we start talking about representation, guys, so whatever way of representation we have chosen, it must be capable of conveying two information about the magnitude and about the direction. Okay, so I think the easiest way to indicate a direction is by using arrows, and that's exactly what we do. To represent a vector quantity, we use arrows. How do we do it? I'll teach you. So have a look at this. All right, so whatever is written on the screen right now, okay, I'm not describing anything from this, I'm leaving it up to you. Consider this like like a puzzle that you have come across while you were chasing some treasure. Okay, so if you find a piece of paper with these details on this, and you need to infer that what these details are, what is the information present here, like what this image is trying to convey to us, what is your what is your conclusion? For example, I see one arrow here, and I see a symbol here that indicates this N is north, this E is east. So this is the bearing, like this clarifies that on this plane which direction is considered as the north direction. Okay, you would have seen such symbols on maps, properly made maps. They would have symbols indicating that which is the north direction. If you open the Google Maps, you see a red colored arrow, you see a arrow like this. Okay, and so this points to the north direction. Like if you you rotate the map, then this also rotates, maintaining the north direction. Okay, so basically when you are looking at a map, okay, this diagram tells you that which is the north direction in this map. Okay, so right now we have this symbol, then we have something written here called something is written like 1 centimeter is 5 Newton. So something is written there. So what do you interpret, guys? Like I think this is an arrow, so this arrow represents a vector quantity, but what is that vector? What information can I draw from this? So if 1 centimeter is 5 Newton and we have a 10 centimeter long arrow, then this arrow must represent 50 Newton, and because Newton is the unit of force, so this arrow should be representing a force. A force is a vector quantity, so it must be representing a force that has got 50 Newton of magnitude. And what about the direction? It's due north, like it's northwards. Okay, how do we describe this? So what we have here, we can describe it in word as we have a force of 50 Newton due north. This is how we describe due north. All right, instead of using the word towards, we use due. It's due north. Okay, let's try some more examples. Okay, you have to try these out yourself. So have a look at this. You can pause the video and you can try it out yourself. I will reveal the answers, in further in this video. So this is your next assignment, like next question. Then try this out, everyone. Pay attention to the units. Pay attention to the bearing. Not only pay attention to the diagram, the direction of the arrow. Also pay attention to where the north is. All right. And one thing is very obvious. Let me go back to here. If this is north, then obviously this direction is south and this direction is west. I hope that much part is pretty much clear to you. I think this the ink was not visible, so I'll do it again. So this is southwards and then this would be westward. So that was pretty much obvious and therefore it was not written there. Okay, so coming back, this is the B, this was the second part. The third part, all right, so try to interpret what information has been conveyed here. Okay, and then this is the D option. Again, guys, I'm moving through these images quickly because you always have the option of pausing the video and then continuing. Okay, so this is your D option or D part. Then this is your E part. Okay, so finish them, everyone, finish them. I hope you have tried them, and now we are going to we are going to do them one by one. So if you have tried them, let's do them. So the first one, this is the first one. 1 centimeter is 3 Newton. We have a 7 centimeter long arrow, so that must be 21 Newton of force. Okay, 21 Newton, and the direction is eastward. So I will write it as a force. I will write it as force of 21 Newton due east. Okay, this is a force of 21 Newton due east. All right, then if I move to the next one, here we have 1 centimeter representing 2 meter per second square, so that must be acceleration. Acceleration is again a vector quantity, and this length is 10 centimeters, so we are definitely talking about an acceleration of 20 meter per second square. And what about the direction? If that is north, so this must be south, so this is due south. Okay, so I will write acceleration of 20 meter per second square due south. Okay, so this is what it represents. This arrow represents an acceleration of 20 meter per second square due south. Okay, this is the next case, the C part. Okay, it here 1 centimeter represents 4 meter. Okay, now that must be displacement. Displacement is a vector quantity. It has got a unit of meter. So we are talking about 1 centimeter is 4. We have 10 centimeters, so 40 meter. We are representing a displacement. Okay, we are representing a displacement of 40 meter due what? Due west. Okay, due west. All right, and then this is the fourth part. Here, this is pretty interesting, guys. This is pretty interesting. 1 centimeter is 4 Newton. We have 8 centimeter long arrow, so we are definitely talking about a force of 32 Newton. But what is the direction? Is it north? Is it east? It's between north and east, exactly between north and east. This direction is called northeast. Okay, exactly between north and east is northeast. Okay, so we are talking about a force of 32 Newton due northeast. Okay, so remember, northeast is a very specific direction, exactly in the middle of north and east, exactly in between north and east. Okay, if it is not exactly in between, how do I know it's exactly between north and east? Because of this 45 degree. Okay, the entire this angle is 90 degree, so 45 degree means exactly midway between north and east. If it is not exactly like here, now the angle is 30 degree, should I say that this represents a force of 40 Newton due northeast? No, this will not be called as northeast. Okay, so let me start writing it here. So we are now talking about a force of 40 Newton due. Now watch it. How we can describe this direction? So from east, from east direction, if we go 30 degree towards north, then we end up in this direction. So we can call it as due 30 degree north of east. That means from east you move 30 degree towards north, then you will end up in this direction. Or the other way to write is 60 degree east of north. 60 degree east of north. Okay, so you can start from north, you can turn 60 degree towards east, so 60 degree east of north. This is the second way to represent. The better way is this, because here you are using a smaller angle, clearly indicating that the direction is closer to the east one. Okay, so please keep this in mind, this particular thing, because mostly the student will end up calling this also as northeast, which is not right. Okay, so if the, I hope the representation part is clear. These are all the 5 answers. Okay, these are all the 5 answers that I've given you. So that was about representation. Now comes the notation. Now what do I mean by that? So in physics you use a lot of symbol for representing different quantities, and there are some usual symbols, like for example, when you talk about mass, okay, when you talk about mass, usually you use the symbol m. When you talk about, let's say, temperature, you use the symbol T. Okay, when you talk about time, you use the symbol T, small t, and so on. You talk about distance, you use D. Okay, so when we are representing vector quantity, we would want to use a symbol that can actually tell us that this symbol represents a vector quantity. So what do we do? Okay, what do we do? We put an arrow over the symbol. Okay, so you see the alphabet A. So if we put an arrow over this alphabet, it indicates that whatever this A is representing, okay, that quantity is a vector quantity. And one very important point, guys, the arrow is always made like this, like rightwards. This arrow has got no relation with the actual direction of the vector quantity that this symbol is representing. Okay, it is always drawn like this. So we don't draw like this, we don't draw like this, because it has got no relation with the actual direction of the vector. It is only it's only a representation that tells us that A represents a vector quantity. Or right now, we like, this is a vector A, we call this as vector A. So A with an arrow over an arrow, it represents a vector. Okay, if we are writing only A, it means that we are talking about only the magnitude of vector A, and we are not talking about the direction, like we are not using the direction anywhere. Okay, and magnitude of the vector is also represented by vector A put in between two bars. Okay, so that is another representation. Okay, another notation. Okay, now what are the terms that we use to represent? So guys, I'll elaborate on this. So let me go back. So this was a force. I could have called this arrow, I could have named this arrow as, let's say, F5 with an arrow over it. So this is how I could have named this arrow. I could have put a name to this arrow, and that name could have been F5. You don't really need to put a subscript here. I'm just putting it because I know that I'm going to use F, more F. So again, this was a force. Okay, I could have named it as F4 vector. Okay, this was a displacement. I could have called it as S. So you see, whatever symbol I'm using as the name of the arrow, I'm putting an arrow overhead the symbol to represent, to indicate that this represents a vector quantity. Okay, this, let's say, acceleration. Okay, this is again a force, let's say F1 force. So like this. Okay, so now coming to the terminology. Okay, the arrow that we are using to represent a vector, this is called the tail of the arrow or the vector, and this is called the head. Okay, so head and tail, pretty simple, easy to remember, I believe. Okay, next, if two vectors are positioned such that their tails coincide, then we call such vectors as co-initial vectors. We call such, for example, if I name this arrow, let's say this is a vector A, this is a vector B, then I will call that A vector and B vector, they are co-initial vectors. Similarly, coterminous vectors would be the one whose head coincide. If the two heads are in the same point, they are at the same point, then such vectors are called as coterminous vectors. All right. Then what are parallel vectors? So parallel vectors are the vectors which are pointing in the same direction. Okay, so these are vectors are called parallel vectors. Anti-parallel are the ones which are pointing in the opposite direction. Okay, so this is parallel and this is anti-parallel vectors. Then if the two vectors are present on the same line, if they are present on the same straight line, then such vectors are called collinear vectors. Collinear vectors, if they are present on the same line. All right. So what are equal vectors? If two vectors have same magnitude and same direction, then only we call those vectors as equal vectors. So equal vectors are vectors with same magnitude and same direction. Null vector is a vector with zero magnitude, and if a vector is having zero magnitude, then the arrow that we are going to draw to represent such a vector will have zero length. Okay, that means the head and the tail will be at the same point, so we'll not be able to identify the direction of such vector. So we call that this vector has an arbitrary direction. That means whichever direction is convenient for you, you can assume that. Okay, so that's null vectors. Now coming to the properties of vector. Okay, and before I do that, guys, I would like to ask you a question here. Okay, so we talked about collinear vector, we talked about anti-parallel and parallel vectors. Can I say that if two vectors are parallel, then they have to be collinear? Is that statement correct? If two vectors are parallel, then they must be collinear. Is that true? No, I don't think so. Same way, if I say that if two vectors are anti-parallel, they must be collinear. No. But if I say that if two vectors are collinear, then they should either be parallel or anti-parallel. What do you think about this? If two vectors are collinear, then they must either be parallel or they must be anti-parallel. Do you think this is correct? Yeah, that statement is right, guys. Okay, now let's come to the properties of the vector. So the first property that we are going to study is called the invariance. It's a brilliant property, very useful property. What does it indicate? So let's say you have a vector A, and what you do, if you imagine an arrow, literal physical arrow that is you are using to represent, for example, this pen. Okay, so if this pen is vector A, you translate vector A, ensuring that you are not changing its orientation, like it is always maintained parallel to its previous orientation. Then wherever you have taken it, it is still the same vector because it has got the same length, it is pointing in the same direction. So this vector is same as this vector. In other words, if you create a copy of this vector in the having the same length, pointing in the same direction, then this copy will be called same as A vector. So if I name this copy as B vector, I can very well say that A vector is equal to B vector. Okay, or in other words, if you translate a vector, if we shift a vector keeping its orientation unchanged, the vector remains unaltered. This property is called invariance. Okay, and we use this property extensively, for our help. For example, if I say that any two vectors must either be parallel or anti-parallel, what do you think, guys? I'm going to bombard you with a series of statements, and you have to identify whether they are true or false. So the first statement is, any two randomly chosen vectors, they must either be parallel, and if they are not parallel, then the only possibility left is that they must be anti-parallel. Is this true? Is this true, guys? No, this is false. Okay, this is false, because there can be a situation when the vectors are like, this is A vector and let's say this is B vector, so they don't seem to be pointing in the same direction, neither are they pointing in opposite direction. So it is not necessary that vectors have to be parallel or anti-parallel. So this statement is false. Okay, so this statement is false. Now let's go to the next statement. So it says any two given vectors must either be collinear or non-collinear. So we have been given two vectors. If they are like, they can be collinear, they can be lying on the same straight line, and if not, then they must be lying on the different straight lines. So yeah, this seems true, because if it is not collinear, the only possibility left for it is to be non-collinear. So this seems true. Then if two given vectors are collinear, they must be either parallel or anti-parallel. We have already talked about this. So yes, even this is true. Okay, this is true. Then using invariance, it is possible to make any two vectors as co-initial or coterminous. What do you think about this, guys? Using invariance, so let's say two vectors were like this, vector A and let's say vector B. Right now it doesn't appear that they are co-initial or coterminous, but invariance allows me to shift the vector keeping its orientation change. So I can very well shift a vector A from that position to this position. It will still be vector A, and now I've made it co-initial with vector B. So yes, this is true. Yes, this is true. And not only is this true, it is very, very useful also, because it will allow you to make vectors co-initial or coterminous as the need is. Okay, a null vector will have head and tail at the same point. What do you think, guys? This certainly looks true. Okay, and then next part, multiplication of a vector by a scalar. Okay, so suppose we have a vector A and we say that, okay, let me say that I have a new vector which is 3 times the vector A. Now this new vector, I'm calling this new vector as B vector. So what will be the magnitude of the B vector and in which direction will it point? So it will point in the same direction as A, and its length will be 3 times the length of the arrow of A. Okay, so A is like 3A, is vector B. If we multiply with a negative number, then the direction reverses. So whenever you are multiplying a vector by a scalar, that means a numerical value, all right, that has got no direction, so in that case you get a new vector which is parallel to the original vector if the constant is positive, and which is anti-parallel to the original vector if you have multiplied with a negative number. And the magnitude changes, if you are multiplying by 3, the magnitude will become 3 times the original magnitude, and so on. Okay, so this is multiplying by a scalar. Now multiplying a vector with a non-zero scalar will always give us a new vector that will either be parallel or anti-parallel to the original vector. What do you think, guys? Is this true or false? I've just talked about this thing, and yeah, it is true. It is most certainly true. Now let us talk about the angle between the two vectors. Okay, what I am going to teach you right now is to identify that which angle is called the angle between two vectors. Right now I've been given two vectors A and B, and I've been asked that identify the angle between these two vectors. I don't see any angle here, right? I don't see any angle here, but I'll have to identify. So what do you need to do? So there are steps actually. The first step is that you make vectors co-initial or co-terminus. It is your wish. Make vectors either co-initial, okay, or co-terminus. All right, so that is your first step. Okay, let me see. So see, here we have shifted vector A. We have shifted vector A to make it co-initial with B. We could have shifted vector A like this, and we could have made it co-terminus with B also. Okay, so this figure demonstrates co-initial figure, and this is demonstrates co-terminus. You are not supposed, or you are not required to make both the figures. Anyone will do. Once you have made this figure, you will now witness angles in both the figures. Okay, here I witness a smaller angle and a larger angle. Here also I witness a smaller angle and a larger angle. So once you have made co-initial and co-terminus or co-terminus, the smaller angle that you witness, that is called the angle between the vectors. Okay, so this is what you need to do, and then the smaller angle is the angle that we are looking for. Okay, the smaller angle now, okay, is called angle between vectors. All right, so we are naming that angle as theta. Okay, so guys, today's session I will cover this much only. I've attached an assignment in which I've talked about whatever I've spoken here in the description of this video. Please try that assignment. All right, and I'll continue vectors in the next session. Take care, everyone. Bye bye.